Part 3. So now we discussed in the previous video about the map reduce, that is two tasks in Hadoop, how we are going to do the map and how we are going to be reduced with the example. Now we are going to see Hadoop component and importance of HDFS. Map reduce and HDFS is very important in Hadoop components. Hadoop, previously I told you that Hadoop is an open source distributed processing framework that manages data processing and storage for the big data application running in the cluster systems. Okay, so now we know why we need. I told HDFS, Hadoop distributed file system. File system, it's nothing but storing or arranging the data. We can say as a file system is arranging, means we need to arrange and predefine the data structure we need to keep. So we have to distribute the data and we need to the file system, we need to be arrange the data. DF stand for distributed file system. It is a concept of storing the file in multiple nodes in a distributed manner. So it is a multiple nodes in the distributed manner. DF actually provides the abstraction for the single large system whose storage is equal to sum of storage of other nodes in the cluster. So as we discussed in the previous, that Hadoop is working in the clustering manner. So here we can say that the single large system storage is equal to sum of storage of other nodes in the clustering. So you can see in the example, the pictorial manner, we have the local file system in the 10 TB terabyte, and we have the DFS, means distributed file system. You can see as individual, you can see here, you can see the individual files, means that is one cluster, means we have one file that whatever the task you want to do, instead of doing in the single database, single processing, we have to distribute it according whatever the file system you kept it a distributor, and you can distribute and you can take the output. So here we can see that I taken as a one example to make you to understand. That is, suppose you have a file of size 40 terabyte to process. Is a one example. On a single machine, it will take suppose 4 hours to process it completely. But what if you use a DFS? See, both the example I shown here, that is, if you take, that is the one, if you take 40 terabyte to process, okay, the same one if you use in the single machine to process, it will take a 4 hours. The same 40 terabyte if you given in the distributed file system processing, then within a 1 hour you can be complete. So in that case, as you can see in the below image, the file of size 40 terabytes is distributed among the 4 nodes in the cluster. Each node store the 10 terabyte of file. As all these nodes are working simultaneously, so it is working simultaneously, parallelly it is working. It will take only 1 hour to complete the process, which is fastest. That's why we need DFS. Even though when you're getting the big data, when we are getting the huge data, as we are distributed that, whatever the process we want to do, whatever we want to be stored, we distributed simultaneously. All the nodes are working simultaneously, so that the time will reduce. So because of that, so you be given the comparisons. When you compare the 4 local file system processing, it will take as a 4 hours. When you take as a DFS, means distributed file system, it will take in the 1 hour. Why DFS? So Hadoop distributed file system is utilized for storage permission in a Hadoop cluster. It mainly designed for working on commodity hardware devices. Commodity hardware device is nothing but devices that are inexpensive. It is very inexpensive. Working on the distributed file system design. Hadoop distributed file system is designed in such a way that it believes more in storing the data in large chunk of blocks rather than storing a small data blocks. That is, Hadoop provides fault tolerance and high availability to the storage layer and other devices present in the Hadoop cluster. What do you mean by the fault tolerance? Even though in the cluster between, if you have 10 clusters, between one or two clusters are not working, it won't be affect your process. It will give the same result because we have the replication in one cluster to another cluster, so it is not depend on only one cluster. It will be having n number of cluster, it is having n number of nodes, so it is a network, means it's connected one to one, so it is giving high for, means it will giving the high availability, moreover fault tolerance. Your work, your performance will be same even though one or two nodes are not working. HDFS is capable of handling large size data with high volume, velocity and variety, makes Hadoop work more efficient and reliable with easy access to all its components. HDF stores in the data in the form of block. Whatever we are taking, it is storing as a block, where the size of each data block is 128 MB in size, which is a configurable, means you can change it according to your requirement. It is possible in the default 128 MB. If you want to be change anything, you can change. That is HDFS dash site.xml file in your Hadoop directory. Students, what I want to say to you people, this Hadoop, Apache Hadoop, you can download. It is a open source and you can access the large scale data also. Now we have about some features about the HDFS. What it is easy to access files stored in the HDFS. Okay, and HDFS also provide high availability and fault tolerance. Provides scalability, scale up and scale down nodes as per our requirement. You can scale up and scale down according to your requirement. Data is stored in the distributed manner because it is, we have n number of node, so it is distributed. Various data nodes are responsible for storing your data. Data nodes, it is very important. In the next slides, we are going to discuss about that. Okay, HDFs provide the replication because with no fear of data loss. I told you that fault tolerance. If fault tolerance nothing but if one or two nodes are, if it is in the under the repair or it is not working conditions, it won't be worry about that because we have the replications and it will give the same performance, so it will work. So you don't need to be fear of the data loss. HDFs provides high reliability as it can store data in a large range of petabytes. So you can share, means you can store how much data you want, huge data you can store. HDFS as in built-in server, so it is built-in servers in the name node and data nodes. Very important in HDFS. These two words, name node and data node, that help them to easily retrieve the cluster information. So that one we will call as a master and slave. Here these two words are play a very significant role in the HDFS. Okay, then it's provide high throughput also. Now we come in a very important topic, that is the HDFS storage, how it is storing. So we want to know that how it is. See, now up to now what it is, what purpose we want to take and what is the features, how it is working. Now we come across that how it is be working. I told you name node and data nodes. These two terms are play very significant role in Hadoop distributed file system. So what we are going to say, this type of architecture we will call as a master slave architecture. That is, HDFS has name node and data node that works in the similar pattern. So name node we will call as a master, data node we will call as a slave. You keep it in your mind. Name node we will call as a master, data node we will call as a slave. Okay, now how it is be working. So first we will see as a master node, that is a name node. What all it is work and what type of the work it's doing. Name node work as a master in the Hadoop cluster. So now we are speaking about the each cluster that guides the data nodes. Data nodes is nothing but slave. Name node is mainly used for storing the metadata. Students, you people know that what is a metadata. Metadata is nothing but data about the data. When you studied in the data warehouse, we come across about the metadata. So the same metadata is working in the name node also. So metadata can be transaction logs that keep track of user activity in a Hadoop clustering. Metadata can also be the name of the file. So you have to know metadata can also be the name of the file. Which type of the file name and size and information about the locations. Which information about the location? In that location, what will be there? Block number and block ID of data node, because this is the master. Name node is a master, so that it will keep the name of the file, size and information about the location. What do you mean by the location? Block number, block ID of data node. That data name node store to find. So it is always working as it is a master. It is having all the power, okay, to control the data node, okay, to store to find the closest data node for the faster communication. It is keep like a tracking. So which is one empty, which is one is having the fast, it is having all the block number and block ID, and which is one empty and which rack they can be occupied when they're immediately when you're getting the used data or the data is keep on coming, it has to be put it as a rack. It will store in the rack. Name node instruct the data node with the operations like it is going like, we can say like a brain, or so it is giving the instructions to the data node what it has to do, what all it will make the instruction can give. You can delete, create or duplicate, means replicate also we can do it, etc. These type of the things can be instructed by the name node. As our name node is working as a master, it should have a high RAM or processing power in order to maintain or guide all the slaves in the Hadoop cluster. Name node receive the heartbeat signal and the block report from all the slaves from the data nodes. So this is very very important in the HDFS. These two things, name node is a master. It is a very very important. It is going to take a control. It is having the metadata. In this metadata, what is a metadata? Data about the data. What it is storing? It's storing the name of the file, size, information about the location. Location is nothing but the block number, block ID of the data node. Not only that, the name that only that name node is going to give an instruction to the data node, which all the time you can delete or you can create and you can use the replicates, etc. These type of the instruction giving, so that it is having the high RAM and processing power to order to maintain in all guidance, means it is giving the guidance to all slaves in the Hadoop cluster. I hope that you people got it. What is a name node? Now I'll go for the data node, that is a slave. What work it is doing? All the instruction getting from the name node, because that is a master. So master is giving an instruction to the slave. The slave is nothing but data node. Data nodes works as a slave. Data node are mainly utilized for storing the data in the Hadoop cluster. So just storing, to store, we are discussing about what is that, why we need the Hadoop. Hadoop is nothing but is a tool, open source. Okay, so whatever the used data we are collecting, we need to be stored in the proper manner in the file system. Okay, so the master is giving and everything instruction according to that the slave, that is data node, is doing. What is doing? It is storing the data. So The data nodes can be from 1 to 500, even more than that also. More number of data node your Hadoop cluster has, more data can be stored. It is having more, 1 to 500, even more also, according how you are creating. Okay, so it is advised that data node should have high storing capacity to store a large number of file blocks. So whatever the data is coming, it is like a blocks. Data node perform operation like creation, deletion, etc. according to the instruction provided by the name node. The slave is, it is only to store, and it is having 1 to 500 or even more than that. So the capacity is very high. It is taking more files, number of file blocks. Two, it is having very storage capacity to store. So what type of operation is doing, like creation and deletions, okay, according to instruction provided by the name node. It is a master node. So you can see in this diagram, name of the node, that is a master. We have n number of slaves. You can keep n number of node. Under that node, data node, under that you can see map and reduce. Already in the previous slides, means previous video, I explained what is map and what is reduce and how it is happening with the examples. So when you are coming for the HDFS, under the data node, how map is reduced, it will reduce, and it will reduce according to the algorithm. It is going to be stored. In this way your data is going to be storing. So I will go for the architecture in the main Hadoop architecture. Hadoop as a master slave architecture for data storage and distributed data processing using MapReduce and HDF method. Students, this is very important, this Hadoop architectures. Now I hope that you got it. You have to make a divisions. First you need to know what is MapReduce. Then once if you know the MapReduce, what is HDFS, then under that how it is be working. So you can take as a layer MapReduce layer, HDFS layer. So how it is a master node and slave node. The both are working as a master and slave. See, when you're coming for the MapReduce, map is a master, reducer is a slave. Master is whatever he giving, that is a map. After reducing and whatever giving the output, according to that it is going to be a reducer. Same way when you're coming for HDFS layer, when whatever the name node is giving, according to the data node is going to be working. This is a architecture for the Hadoop architecture. So this is also one more example to make you to understand. I took one more example. You can see as the client is submitting and the job track. Job tracker is nothing but we can say as a name node, that is a master. Then it is be as a one cluster. Status update, that is a one data nodes. That is 3 task trackers on the 3 data nodes. Under the task we have map reduce. You can, which is the example you feel that is so easy, which is a diagram you feel like to explain, you can take it down and bit, but both are the same, but only you need to understand the concept and you have to know that. So now I hope that you students come to know what is Hadoop. Under the Hadoop, what is the MapReduce and what is the HDFS. So I given that MapReduce one video, separate video, and HDFS separate video with the example how it is be working. Though the next video I'm going to explain about the echo, means Hadoop ecosystem. What it is, very important topic. Thank you.